Okay, so now we are here in problem 767. Este, so we are already given like a markup, a markup chain, the transition matrix. The first question is very easy. What is the meaning of 0.9? So read the problem. What does the problem mean? What does it mean to, o sea, what is the meaning of each of the transitions? And if you read it, you will know that that means that 90% of probability of a non-vegetarian remains non-vegetarian. That is the meaning of that zero point 0.9. Okay, now they are asking us for the eigenvalues of the matrix. Remember that when they are asking us for the eigenvalues, we need to solve the a characteristic polynomial. O sea, remember this formula is in your booklet. The determinant of a minus lambda I equal to 0. So that is the determinant of a 0.8, 0.2, 0.1, 0.9 minus lambda 1001, o sea, which is the same as the determinant of 0.8 minus lambda, 0.1, 0.2, 0.9 minus lambda equal to 0. Then remember the determinant formula, and for the determinant formula, you only have to do 0.8 minus lambda times 0.9 minus lambda minus 0.1 times 0.2 equals to 0. And to solve for this equation, it is a quadratic, so I'm just going to graph it. I already have here uh, my other graph, o sea, the last time that I did this, so let me just do it again. So it is 0.8 minus x times 0.9 minus x minus 0.1 times 0.2. Up is the same. Okay, and you analyze is the analyze graph, find the zeros, no, and with this function you find that your both eigenvalues are 0.7 and 1. So your eigenvalues are 0.7 and 1. Okay, one of the eigenvectors is 1, negative 1, 1. How do we check which one is this? O sea, how do we check what is the associated eigenvalue to this vector? O sea, I know that this is an eigenvector, but what is the eigenvalue? O sea, does this vector comes from 0.7 or does it come from 1? And how do we check it? Well, let me go back to the calculator. I am gonna create my matrix that is 0.8, 0.2. Okay, and I am gonna multiply it by the given eigenvector. So this is negative 1, 1. Okay, so observe that this vector it is in the same direction, o sea, of the result, but with a different scale, no? O sea, what I can conclude from doing this calculation is that the eigenvalue associated to this eigenvector is 0.7, no? O sea, porque when I do a times negative 1, 1, I get then negative 0.7, 0.7. O sea, which is the same as 0.7 times negative 1, 1. O sea, the eigenvalue is 0.7. So how do I find the other eigenvector? I need to find it for a lambda equals 1. O sea, I need to solve for 0.8, 0.2, 0.1, 0.9, xy equals to xy. I could also find like this matrix to a higher power, no? Eh, but let me do this, no? Porque I have been doing this. So this is the same as 0.x plus 0.1y equals x, 0.2x plus 0.9y equals y. And because I am very lazy, I am just gonna, and I've done this many times, I'm just gonna copy this. I'm gonna paste it here and just let me make it, let me just fix the numbers. 0.8x and 0.9y. Here is 0.1, and here is just 1 and 1. Okay, so the eigenvector that it's giving me for this eigenvalue, the calculator says 0.5. The calculator is, if I just plug in a c5 equals to 1, my eigenvector would be 0.5, 1. This is the other eigenvector, no? And observe, this eigenvector and this eigenvector are not the same. Great. Also, they are not the same and they are not even parallel.